Hello everyone, and welcome to today's session on optimizing cost in Amazon S3. My name is Christoph Bartenstein. I'm a Principal Product Manager here in Amazon S3. I'm very excited today talking about cost optimization. I'm aware it's the last session of the day, so I have to compete with the after party, but I hope I can bring some excitement with saving cost in S3, how to drive cost efficiencies, and how to be effective here. So we have a full agenda in the next hour. We'll talk a little bit about Amazon S3, give you a quick overview about the service, talk about the storage classes. Then we talk about the pillars of cost optimization. And so those are really the steps we think about taking when to optimize cost and how to optimize cost in S3. Then I'm super excited to talk more in detail about a new storage class we launched just 2 days ago, S3 Intelligent Tiering, which is a fully automated cost optimization storage class. And then we'll talk about Pinterest, and we have a special guest here today. So Pinterest will share with us how they use S3, how they drive cost efficiencies, and what storage classes they use, what features they use, and how they use S3 in a very efficient way. So with that said, let's get started. So let's take a step back before we go too deep into storage classes. And when you think about your storage infrastructure, when you think about what happened over the last years in your organizations, in your companies, then chance is good that over time, requirements have changed for storage. And so storage today needs a lot of different things. It has different requirements, it has different workloads, and the storage you have in your company is probably not just like one solution. And so what we did is we built a broad portfolio of storage solutions that you can house all your storage in one place. It ranges from object storage to file storage to block storage. Has tons of features on top. And today, I want to talk about object storage. And when you talk about object storage, we think about Amazon S3. And in Amazon S3, you have different ways how you can store your objects. You have different storage classes. So you see that on the right side here. So you have S3 standard, standard infrequent access, et cetera, et cetera. So your different storage classes provide you a different way how you can store your data at different price points. And today, we'll talk about how you can use all these storage classes in an efficient way, how you can move data between these storage classes, and what storage class really works well with what workload. So let's talk about the pillars of cost optimization. So when I talk about pillars, it's really the steps, the things you have to do in order to optimize your cost. And the first pillar is all about your applications. It's all about the requirements of your applications. So when you step back and think about defining application requirements, is really essential if you want to drive costs down. Because every workload, every use case, every application might have a very different requirement for storage, from milliseconds latency to hours retrieval times, from durability to redundancy. I'll talk more about what all those requirements are and how they impact your cost in Amazon S3. We'll talk about how you need to organize your data, how you can organize your data, and the tools and features S3 provides you to organize your data in an efficient way. And the reason why this is so important in context of cost optimization is because if you organize your data the right way, it's much easier to optimize cost later on. We talk about right sizing, which is the third pillar of cost optimization. And right sizing is really choosing the right storage class. Don't choose a storage class you don't need because you can go to a cheaper storage class. You can right size and really use for whatever workload you have. And S3 provides you several storage classes, and I'll give you later on a detailed overview about the trade-offs you make with them. And the last piece is really a continuous optimization. We talk about monitoring your storage, analyzing your storage, and optimizing your storage. And as you can see with this nice circle, this is not a one-time step. So you don't do this once and then forget about it. You continuously do it. And I'll show you what features and tools S3 has to do that. Let's talk about defining application requirements. So that is really something you know best. So you know your applications best. So what is the durability and redundancy you want from your storage? What's the availability do you need? Do you need 99.99%? Are you okay with 99.5%? So what uptime do you need for your applications? What access frequency do you have? So access frequencies go from milliseconds every minute to once a month, once a year, once a day, once an hour. So it really depends on you. We talk about performance, so when you access your storage, what performance you want, what first byte latency you want. We talk about the object size. Because it's object storage, the object size really matters when it comes to cost. We talk about the duration. So how long do you keep your storage in S3? Do you keep it for hours? Do you keep it for years? Do you delete it very often? So all that drives your decision what storage class you want to use. And because the storage classes have different price points, that drives down your cost. And when you step back and think about all those different workloads in S3, from content distribution to file sharing to backup to analytics workloads to disaster recovery workloads, it's very simple to say all these workloads have very different requirements. So again, it's up to you to define these requirements and then use the storage class that best fits. The second pillar of cost optimization is to organize your data. And I'll make a quick flyby here, and then I'll give you an example of a customer and how they organize your data. So in S3, you can organize your data not only on an account level or on a bucket level, but you can also get down to a prefix level, or you can go down to an object level. And S3 provides you a feature called object tags. So you can tag each object, and each object can have up to 10 mutable tags. And because you can tag each object now, you can control, organize, and optimize your storage on a very granular level, on an object level. And so we have customers with hundreds and thousands of millions of objects. And so it becomes really important to optimize your cost, not for all of your storage the same way, but you can do it on a granular object level. So let me give you an example. We have a customer in the media and entertainment industry, and that customer tags the storage. And it tags the storage based on if the workload is a production workload or a development workload. And for the development workload, that customer knows that after 90 days, there shouldn't be any more access to the storage. That storage shouldn't be used. And so after 90 days, the development workload should be automatically deleted, the storage for that. So in that case, you don't accumulate storage you don't need. You use the tags for each object to optimize your storage cost by deleting your storage. So one example, there are tons of different examples. I'll show you later on how you can control access, analyze usage, manage your lifecycle policies on an object level, and really drive down your cost. So second pillar, cost optimization based on organizing your data. Let's talk about the third pillar. I talked about right-sizing. And right-sizing is a complex topic, so let me walk you through some of the decisions, some of the trade-offs you have here. Because we have different storage classes, you can choose different optimization patterns, and you can choose what you want. So for example, all of our storage classes provide 11 nines of durability, but there's different redundancy. You can choose a storage class which stores the data in one availability zone. You can choose a storage class that stores your data in a minimum of 3 availability zones. Or you can choose a storage class and then replicate your storage to another region. So effectively, you store your storage in a minimum of 6 availability zones. And what it really means is, if you choose a storage class with a minimum of 3 availability zones, then they're designed and architected in a way that an entire availability zone can go down and nothing happens to your data. So you wouldn't see the impact, because the rest, the 2 availability zones in that region, withhold that. And there are some other pieces you want to consider. Let's talk about availability. So availability, our storage classes go from 99.99% down to 99.5%. And while the percentage is very small, if you know the uptime, we talk about several hours difference. So there is a difference in availability, and you want to choose the storage class that best fits your workload. We talked about access frequency. I talked before about that. We talked about performance. You can choose a storage class that gives you milliseconds, like S3 standard or standard infrequent access, or you can choose a performance like in hours, like asynchronous, like S3 Glacier. Or there's a new storage class pre-announced, I think it was yesterday, like S3 Glacier Deep Archive. We talk about other characteristics, how big your objects are. And the important message here is that depending on your characteristics, depending on the storage class you choose, you can reduce your storage cost by more than 80%. So the difference between the storage price of S3 Standard down to S3 Glacier is more than 80%. Let's talk about the fourth pillar of cost optimization. Let's talk about, very quickly, how to monitor, analyze, and optimize your storage. So we have different features in S3 to do that. And we talk about our building blocks. So you have storage classes, and I'll talk in detail about the storage classes. But then you have also features to think about how you can move different storage to different storage classes. You have S3 inventory. So S3 inventory gives you a list of all your objects. It's a report of all your objects. And you can store that in a bucket. You can do that on a daily or weekly basis. And that means you have information of all the metadata of an object, of all your objects, in one file. You can then query that file. It's on a CSV format or RSC format. You can use Athena. You can export that file and use QuickSight and show certain trends. So we have a customer, for example, they use S3 inventory to run their garbage collection. So what they are doing is, they know that in S3 inventory reports, they see the creation date of an object. And every object that is older than 120 days, they run a script, and it's automatically getting deleted. Another customer uses S3 inventory report to figure out in what storage class each object is stored. And that tells them how much of the storage, or how much of their storage is in standard versus standard infrequent access, for example. So it's a very powerful tool to give you on a very granular level information about where is your storage stored, in which storage class, what is the metadata behind, what is the encryption status, what is the replication status. So tons of metadata information in that inventory report. We have two more other features how to analyze and then optimize your storage, called S3 storage class analysis and S3 lifecycle policy. And those two work really well together. I'll give you later on more examples, but essentially, you can analyze your access patterns with S3 storage class analysis and then move storage which is infrequently accessed from a frequently accessed storage class down to a less frequently accessed storage class. And because frequency drives cost, you can save money by going from standard to S3 standard infrequent access. The way how it works is you choose storage class analysis on a bucket or prefix or tag. It lets you run for a few days, 48 hours, and it gives you a report and it shows you at what age, so for instance, after 30 days, after 60 days, or after 90 days, your storage is infrequently accessed, and then you can use that information, plug it into a lifecycle policy, and move storage from S3 standard to standard infrequent access. So you have these features in building blocks, and it works really well for predictable workloads because, as I said before, the age of an object correlates in a predictable workload with the access of an object. That means the older an object is, the less it is accessed, and therefore older objects are less frequently accessed. You can move it to a less infrequently accessed storage class. That doesn't work very well if your access pattern is changing, and if you don't want to do that work of S3 inventory, analyzing, monitoring, and then moving, you can also use our new storage class S3 intelligent tiering, which is doing all these steps automatically for you on your behalf. And I'll talk much more about how that really works, what the trade-off is, and for what workloads it works really well. So let's talk about the storage classes and the options you have. In S3, you have 6 storage class options. So the way how we think about storage classes, in 2006, so more than 12 years ago, we started with S3 standard. And over time, we added more storage classes. And we added these storage classes because we saw demand for them. And we developed them to provide you the lowest cost for a specific workload. And so when you step back and think about the storage classes, they're really a reflection of our AWS pricing principles. And the AWS pricing principles is something that is around for, well, 12 years now. It's not specific to S3. We talk about there's no upfront investment. So what you can see in S3 is you don't need to invest in anything. You can just use S3. And because there's a pay-as-you-go approach, you don't pay for things you don't need. So you can scale up and scale down. You can use S3 storage. You can scale down by deleting S3 storage. You can use it more. And I talked before about the duration. There are workloads which delete it a lot, like on a daily basis. So you don't need to provision anything. You can just use it as you go. At the same time, the third principle kicks in, which is you pay less when you use more. And that is integrated in the offering of S3 standard. So S3 standard as well as S3 intelligent tiering, both storage classes have volume discounts included, which means the more you use the storage class, automatically the less you pay for it. And the fourth principle is something I want to talk a little bit more about. So you pay less as AWS grows. And it's really interesting because we innovate on your behalf. And when you think about it, we launched more regions, more availability zones, and more storage classes over time. In addition to that, we reduced prices over time. And the next slide shows you those two vectors, and it shows you what happened over the last 12 years. So over the last 12 years, we decreased storage prices by more than 80%. So that means in average, every year storage prices go down by about 15%. At the same time, we accelerated innovation. And we added more and more storage classes to the portfolio. We started with S3 Standard in 2006, added S3 Glacier in 2012, S3 Standard Infrequent Access for infrequently accessed data in 2015. And then earlier this year, one-zone infrequent access. Then this year, at the beginning of this week, intelligent tiering. And then yesterday, at the keynote, we announced the coming soon of S3 Glacier Deep Archive. And so what you can see is, on the one hand, we reduce storage prices because we innovate on your behalf, and on the other hand, we accelerate innovation and provide you more ways how you can store your storage on S3 in a most cost-effective way. So let's talk about the different storage classes and how they really compare. So I talked a lot before about the requirements we have. I talked before about that it really matters that you organize your data. But at the end of the day, you store your data in one of these storage classes. And we have 6 of them. So in S3 Standard, it's really ideal for frequently accessed data, for active data. So for example, if you continuously access your data for analytics, for big data workshops, for Hadoop workshops, when you go in there and say you want to access your data on a daily basis a lot, then S3 Standard is ideal. It stores your data in more than 3, in a minimum of 3 availability zones. It has milliseconds access, so high performance, high throughput, and has a storage price of about 2.1 cents per GB in IAD. If you don't frequently access your data and infrequently access your data, then standard infrequent access, the third storage class, is really ideal for you. So think about a backup workload, or a mobile backup workload, or a disaster recovery workload, where you just don't access your data all the time. But if you want to access your data, then you get it back in milliseconds. So standard infrequent access is for infrequently accessed data, but if you want to have milliseconds access, so high performance again. It has a 40% lower storage price than S3 Standard in IAD again, but you pay retrieval fees. So it's really for storage you don't want to access on a monthly basis. You maybe want to access it once every 2 months, once every 3 months, maybe once a month, but not every day, not every hour. We have, if you have infrequently accessed objects, and you also care more about cost than about redundancy, you can use one-zone infrequent access. And one-zone infrequent access, the difference to standard infrequent access is it stores the data in one availability zone. So therefore, the cost goes down again. And so when you think back now what I said before about defining the requirements, if you don't need high redundancy because this is your secondary backup, one-zone infrequent access might be a really good option for you. We obviously have S3 Glacier, our archive data solution, which is really for storage you want to archive. You don't want to access all the time. It's asynchronous, so applications work differently with S3 Glacier. So the retrieval times is in minutes or hours. You can choose that. And it's for archiving at a very, very low storage cost price point. And then since yesterday, we have S3 Glacier Deep Archive, which is, there are so many zeros in between the price that I say it's a fourth of the S3 Glacier price. So it's a very, very low storage cost for long-term archive if you hardly access it, or if you maybe don't access it at all. So what you can see here is the frequency of your access really matters. And each storage class is for different workloads. I'll give you later on a little bit examples about what workloads fit really well with each storage class. And so the question is now, I gave you an overview of the storage classes, but how can you choose what's the right storage class? How can I move between storage classes? Well, in S3, we have features like S3 storage class analysis and lifecycle policy. And I talked before a little bit about that, but let me show you in more detail how it works. So if you have storage in S3 Standard, because that's a general purpose storage class, you just start there, and you start optimizing your storage. Then you choose a bucket or a prefix or a tag, if you tag your objects, and switch on storage class analysis. And then after 48 hours, you get a report, you get recommendations based on the storage age group, and which tells you, and you see that here on the graphic, that based on a certain age, your storage gets infrequently accessed. And let me talk a little bit about what infrequently accessed means. So you see here essentially two bars. The one is storage, and the other one is the amount of data retrieved. And so if the data retrieved in a given month is less than 100% of the data stored in a given month, then we start talking about infrequently accessed. It will go down further on. But if you retrieve more than you store, so you constantly retrieve data on a monthly basis, then you talk about a frequently accessed workload. So in this case, it shows you that, I believe after 90 days, your storage is infrequently accessed. And it gives you a recommendation that that storage is ideal to move from standard to standard infrequent access. And you plug that information in a lifecycle policy. So you say after 90 days, so after an object is 90 days old, it moves from standard to standard infrequent access. And that way you can save about 40% storage cost. Again, it's really good for predictable workloads. I mentioned this before, I want to emphasize it. Predictable workloads meaning the correlation between the age of an object and the access of an object. And as I said before, a lot of customers told us that works great for some of our workloads, but it really doesn't work for several other workloads. So for that reason, we created S3 Intelligent Tiering. It's a storage class we launched 2 days ago, and it's really for workloads with changing access patterns as well as unknown access patterns. So if you don't know if it's frequently accessed or infrequently accessed, and if you don't predict what the access patterns are, if it's changing over time. And the really cool thing about this storage class is it automatically optimizes your storage cost. So let me talk a little bit about that. S3 Intelligent Tiering has 2 access tiers. One is optimized for frequent access, and the other one is optimized for infrequent access. And we created this storage class so that customers save costs automatically when access patterns change. And the really interesting thing about this is there's no performance impact moving from one access tier to the other access tier. It's the same performance as in S3 standard. It's milliseconds latency. It's a high throughput. There's also no management overhead. So what I talked before about if you want to use monitoring, analyzing, and tiering, or you can use the storage class, which automatically is doing all those steps for you. So it automatically monitors your objects and automatically tiers your objects. And the third piece is there's no retrieval fees. In standard infrequent access, I mentioned before, there's a cost to retrieve objects. Intelligent tiering monitors your objects, so therefore there are no retrieval fees. It automatically moves it back to the frequent access tier. So for workloads which are changing, it's a very powerful storage class. So let me talk a little bit about, because it's so new, how we came up with it. What's the story behind? And the story behind is very, very similar than more than 90% of our other products, which is it starts with you. You told us to build this, and so we built it. And the reason why is because you told us it's really hard for unpredictable workloads, for workloads where fragmented applications access S3 buckets to figure out the access pattern. And then you also told us, well, we're not in the storage business. We are in the business of healthcare, automotive, or oil and gas, or whatever the industry is you are in. And so optimizing storage is not necessarily something every company wants to do and has experience in. And at the same time, we realized, well, we're in the storage business, and we're in the storage business now for more than 12 and a half years. So we have unmatched experience in optimizing storage. We have more than 1 million customers, more than trillions of objects, and regularly peak at millions of requests. So we have seen a lot of access patterns, and we fed all this information in an Amazon machine learning model, and that predicted access patterns on a very granular object level. And that helped us to come up with S3 Intelligent Tiering, this new storage class. So how does S3 Intelligent Tiering really works? What is really the trade-off you have? So S3 Intelligent Tiering, as I said, has 2 access tiers. One is priced the same as S3 standard, and one has the same price, a lower price, as S3 infrequent access. And it moves your objects between those 2 access tiers. It monitors your objects and monitors your storage on a very granular object level. So it moves the storage on an object level. And that's very unique when you think about it. So now you can not only optimize your storage based on a bucket or based on a prefix, you can optimize your storage based on an object level. In order to do that, we have a monitoring fee, which is $0.0025 per 1,000 objects. And in order to do that, it monitors your objects on a daily basis. On a daily basis, it decides if it should move an object from frequent to infrequent or from infrequent to frequent. It moves your objects if they're not accessed for 30 consecutive days from frequent to infrequent, and if it's accessed, immediately from infrequent to frequent. Again, there are no performance issues, there's no performance impact, there's no overhead, and there are no retrieval costs for you. At the same time, it is milliseconds access, the same as S3 standard. It stores data in a minimum of 3 availability zones, and it's really ideal for changing access patterns where we don't know what's happening, so unpredictable, and if we don't have the experience in optimizing storage. And that's the use cases we see. So let me talk about a little bit more each of the use cases, and I'll give you an example of them. So let's talk about unpredictable workloads. So access patterns which are unpredictable. So we have a customer who stores satellite images. And these satellite images are accessed very frequently at the beginning of the life because it's interesting, there are projects around, and they're just accessed a lot. Then after some time, it's cooling off. And so these images are not looked at for some months, sometimes half a year. But once in a while, an event happened, like a disaster, another event, like an earthquake, or whatever it is, and a lot of interest comes to these pictures again. So in that case, these satellite images are accessed a lot again. And it's completely unpredictable when they're accessed. So as the intelligent tiering, because it monitors all your objects, it automatically moves them from the infrequent access tier back to the frequent access tier, and customers can just access it again with no performance impact. So that was about unpredictable workloads. Let's talk about changing access patterns. With another customer in the healthcare industry, we talked with them, and they have the issue, they have hundreds of data scientists on a daily basis, they store objects in S3. That customer uses S3 as a data lake. And so because each of these data scientists accesses the objects and accesses the storage, it's very, very uncertain how they use it. Some of them store it and forget it, some of them store it and use it more and more, they access it a lot. So for these use cases where you have a lot of fragmented applications and a lot of different users accessing your buckets because they need to do something with the data, those access patterns are changing. And S3 intelligent tiering, again, if an object is not accessed for 30 days, it moves it automatically to the infrequent access tier, and this customer would save money on that. And the third piece was around experience. So I'll talk a little bit about that we have unmatched experience, but a lot of customers told us that they have actually not experience in optimizing storage, and they don't want to do it because they have a lot of other things to do. And there was a theme around economics as well. So we talked with a lot of startups around, for example, storing data and then optimizing data, but you need to hire someone to optimize. It's not economical. So I'll give you an example. If you store a petabyte in IAD in S3, it's a petabyte, this is roughly about like $20,000 a month, or about $240,000 a year. So now you can save money if you move all your storage to SIA. Most certainly it's not all your storage, but you can save, let's say, about $100,000. But in order to do that, some customers told us they would need to hire now someone to analyze it. And so that's hard for some customers. And so for that reason, the third use case is really if there's no experience in optimizing storage, or it's for workloads where there's just like not any focus on it. So with that said, let's talk a little bit more about cost optimization patterns and what we have seen, when to use what storage class. And again, this is a difficult topic in terms of we have seen a lot of workload patterns. When you look into S3, there are effectively all different kinds of use cases and industries represented. So I'll give you an example of that. Before we start into, let's talk about the different storage classes. So storage classes are part of S3. So because they're part of S3 and they're the way how you store data, they get the same advantages, right? So S3 has industry-leading performance, scalability, and availability. You have unmatched security and compliance. I didn't talk today about that, but there are tons of features around that, tons of talks about that this week. You can optimize each storage class on a granular object level, which is very unique. And then you have different options with storage classes that really fit your workload. And on top of that, you can use all of our analytics services, like S3 Select, Athena, Redshift, or EMR. So S3 is a very powerful data lake. And the S3 storage classes are the way how you can store data. So let's look into the different workload patterns. Let's talk about frequently accessed data. So let me explain this graph for a little bit. So the blue shade is storage. So over time, you can see storage grows, and the pink one is the amount of data retrieved. And below in the second graphic, you can see the ratio of storage to data retrieved. And I talked before about this 100% ratio. So here you can see that about 200% of storage is retrieved every month. And that means that's a pretty frequently accessed data workload. Sometimes these workloads have small objects. So let's assume in that case there's a small object workload. And the storage duration oftentimes is not very long. We talk about some days sometimes, some weeks sometimes. So there's a lot of churn through data. So some of those workloads are, for instance, for DNA sequencing, where you just like use a lot of the data. You delete it again and you use it again. Another workload is for IoT sensor data. So let me give you an example how that worked with one of the customers I worked together. So they have like tons of devices out, and they store all of their IoT sensor data in S3. And these objects are very small. So they store them in S3 standard because they are small objects, it's hard to optimize them. And then on top of them, they do analytics. So they analyze that data. And what they do is they store the results of those analytics in large files. And now that's where you can optimize again, because these large files, they are not stored in S3 standard. They are today stored in standard infrequent access. Or going forward, there's the potential to be stored in standard intelligent tiering. Because they are large, the chances that they are not accessed that much because it's a result of an analysis. And so therefore, they can be optimized. Again, frequently accessed data, very small objects, S3 standard is the right storage class. Let's talk about infrequently accessed data. Here the opposite is true. So over time, you can see that the amount of data retrieved goes down. So we see workloads like that when it's customer-driven content. So customer-driven content is a typical example where at the beginning of the life, objects are accessed a lot, and then after some time, it just flows down. After some time, it cools down, and the access goes down. So examples are mobile sync and backup workloads, data logs, media assets. So all these workloads where there's a lot of interest in the data at the beginning, and then over time, it's less accessed. And what you can do here is that you can store your data at the beginning in S3 standard, and then use our tools like storage class analysis to figure out what to move, and then move it into standard infrequent access. Or if it's a secondary copy, move it into one zone infrequent access. Or, and that's the new way which we have now since 2 days ago, you can use S3 intelligent tiering if you don't want to do those manual process of monitoring, analyzing, and tiering, and just let the storage class S3 intelligent tiering do the cost optimization for you. The third workload pattern is a really interesting one. We talk about changing access patterns. And while it looks a little bit funny, it's a workload pattern you see quite a bit. Let me give you an example. For instance, we talk about financial transaction records. And there's a company who is analyzing financial records. And they're analyzing it once a year, once every 6 months. And so what's happening is, at the beginning, there's a lot of access for it. You can see that here because the graph, the pink graph, is very high at the beginning. So the retrieval rate is like 200, 300%. Then after the access of that data, so after some time, for like 2 or 3 weeks of analyzing, this data cools off. So for several months, the data is now cold. But then after half a year, that process starts again. Or after a year, that process starts again. So it's getting hot again. And if you just move from standard to standard infrequent access, that wouldn't work very well because it's hot after some time. But S3 intelligent tiering, this new storage class, works really well because it moves data around. And it does that without you doing any management behind it. And the last workload we talked about is the workload we just don't know what's happening. And that workload depends on how much you know about it. If you really don't know anything about that workload, if you don't know the object size, if you don't know if you delete it tomorrow or delete it in a year, and you don't know how it is accessed, then S3 standard is a really good storage class option. If you know at least that the object size is large and that it's not deleted for 30 days, so it's more for long-term duration, then S3 intelligent tiering makes a lot of sense. So I talked a little bit about the different storage classes. I talked a little bit about the different features, the trade-offs between the storage classes, and how that all works together. And so I want to tell from the theory and from some examples I gave you and talk about Pinterest. And Julian from Pinterest will give you an overview of how Pinterest uses S3 in an efficient way, what storage classes they use, and how they drive cost efficiencies. Hey, Julian.
Thanks, Christoph. Hello, everyone. It's a great pleasure to be here today to share about how Pinterest is thinking of our storage efficiency and how we are leveraging the different tools and storage tiers that Christoph just mentioned. My name is Julian Wang. I'm an engineering manager from Pinterest, the engineering team. In case if you haven't heard of Pinterest, we're a place essentially trying to help people discover and do what they love. Each month, we have about more than 250 million users using our site, which are creating a huge volume of data. And this is an example page from our mobile web, where you can see people are collecting their ideas and group them into different boards. For us to be able to serve this service, AWS S3 is really playing as a fundamental piece of infrastructure for us. We're using it for many different types of purposes. For example, we use it to store all of our images and videos. We also use it to take off our online storage backup, like MySQL and HBase cluster. And I think one particularly interesting use case for us is we put off our entire data warehouse data on top of S3. For example, all of our users' activities raw log, as well as the intermediate tables derived from it. We use them for business reporting, experimentation, machine learning. All of those data lives on S3. And the convenience for us doing so is that we don't need to maintain a large HDFS cluster where we have to worry about all the complications like data redundancy and durability. But on the other side, it does create a multi-hundred petabyte of storage efficiency problem for us to solve. So this chart sort of tells the story that is happening behind the scene. On the x-axis, it shows of our timeline that was from mid last year to this year. And the blue curve is showing our standard usage. And as you can see, from May 2017 to June 2018, we had pretty significant growth in terms of standard usage. There were some small dips here and there, which were coming from one-time optimization we put in, but the overall trend has been pretty concerning for us. And for that reason, around May this year, we kicked off a centralized storage efficiency program that aims to bend the growth curve and cut down the cost. And as you can see, from June this year, we had some decent job, consistent job in terms of standard usage. And this is also the time where we started to move more infrequent access data into Glacier for cost efficiency gains. So in the following, I'm hoping to share a little bit more of the story happened behind the scene of how we are thinking of our storage efficiency strategy. Overall, there are three major pillars of it. The first is around the tooling and visibility. And the second is the systematic optimization. That is the actual governance work we put in terms of driving down the cost. And the last is the collaboration and the partnership we had with the AWS team. So let's first look into tooling and visibility. For tooling and visibility, the backbone of all of the in-house tools we built is powered by the server access logging feature provided by AWS. By enabling this feature, it essentially provides us with information of object-level access around who and when certain object is being accessed. For us, one problem is that the server access logging data itself is stored on S3. And this data itself is like a multi-petabyte for us. So to make this data easily consumable and queryable, we have a Spark pipeline that happens beneath the scene to aggregate this data. We also have a lot of customized business logic that trying to parse the data and aggregate them depending on different use cases. And so largely, we generated two sets of tables. One set of table is what we call the inventory table. That is essentially giving us the size information of each use case or prefix. And the second set of table is what we call the access insights. That is essentially telling us who and when is accessing certain use case or prefix. So based on these two sets of tables, we are able to build a lot of customized analysis and tools in-house to power our unique use cases. For example, this is an example query that we run all the time. That is essentially telling us what are the top growing use cases from last month. And by doing so, we could identify any new large use cases or detect any potential anomalies with the existing ones. And another example on that is that we run a lot of deep analysis based on the data set. And this is one of the analysis. Essentially, we are trying to visualize our storage usage by different use case and map that to like what a traditional disk usage graph looks like. So in this chart, each color is representing a different use case. One interesting observation for this is that the storage usage distributed very unevenly across different use cases for us. So even though we have thousands of different use cases or like storage tables, majority of the storage space was actually taken up by only the top few use cases. This kind of guides us through where we should put our effort in terms of actual optimization. And then this is another tool we built that essentially sending out alerting email every day to different storage owners to help us drive awareness of their storage use case and help to nudge people cutting down growth. That's pretty much it for the tooling and visibility. With tooling and visibility we build in-house, it comes to the actual optimization and the governance we put in to drive down the usage and bend the growth curve. For us, when we're thinking about optimization, there are mostly three approaches that we are leveraging. The first is the garbage collection. Essentially, with the access insights table we mentioned earlier, we are able to tell, for example, which data set hasn't been accessed for like over a month. And then we can use this information to negotiate with the different data owners and to set up a proper retention policy and garbage collect and use the data. The second major approach we are taking is around the better compression algorithm and the file format change. So for legacy reasons, a lot of our data was stored either in text file format or in sequence file format. By moving these tables to Parquet, sometimes we found it can help us to like reduce 90% of the storage space because it compresses better. And then last but not least, we are also heavily rely on the different storage tiers that are provided by AWS. We set up a lifecycle policy to move data around for cost efficiency gains. So this is a concrete example that is one of our bucket for a use case where we store all of our raw logs. And what happens is that by leveraging Glacier, which is a yellow curve shown in this chart, we could effectively control of our total cost of shown in standard, which is the blue curve. And also at the same time, without being in a situation that the cost is unsustainable. So overall, the storage optimizations that we have put in have helped us save tens of millions of dollars each year. And the last pillar of our storage efficiency strategy is the collaboration we have with the AWS team. The AWS team has done a fantastic job in terms of answering our questions and coming up with the solutions to help solve the challenges we were facing. And in return, we were constantly providing feedback and also piloting with some of the new storage tiers. For example, for us, we are really excited about the new upcoming intelligent tiering feature, as well as the deep archive feature. I think both of these different storage class could help us save a ton of money without all the engineering work and the manual work happen behind the scene. That's pretty much it for the optimization experience from Pinterest. In terms of future work, we are hoping to look into more of a budgeting type of solution to drive awareness like within Pinterest around the efficiency. And also access control is something that's always a constant topic for us, which is not only matters for efficiency purpose, but also for other like legal, for data privacy requirements. Next, I'm going to hand it off to Christoph to give a summary and also a Q&A.
Cool. Thanks, Julian. Okay. I love Pinterest. I have my own board. I'm totally into architecture. So anyways, putting it all together, I think it's really important you understand your applications, because if you understand your applications, you can define requirements, and because you define requirements, you can later on drive down your costs. Use tags and prefixes, because that really gives you the opportunity to go down on a very detailed object level. Optimize across all your storage classes, so it's not a one-size-fits-all approach. If you look at customers like Pinterest, they'll use all different kinds of storage classes we offer them for the different workloads they have, for the different storage needs they have. Cost optimize based on object level, and the new S3 intelligent tiering as well as deep archive is a really nice new addition to the storage class portfolio. So customers tell us all these reasons really enable them to be more innovative, more agile, which makes us happy. And so with that said, I want to say thank you. That was a great and interesting discussion with Julian from Pinterest. I had a lot of fun. We have a little bit more time, so if there's any questions, there are some mics here. I'm happy to stick around if there are any FAQs. Otherwise, thank you very much for being here. Thank you very much for listening. Enjoy the party later on. And please complete the survey. Thanks. Cool. Question. Is it working? Why don't you shout out the question and I repeat it?
Oh, there you go. Whoa. All right. Very quick question. So, aside from the extra fee per number of objects, is there, assuming you don't have millions and millions and trillions of objects, is there any downside of just pretty much running anything on intelligent access?
Intelligent tiering, I think, is a storage class. If you have long-term storage, so there's a minimum storage duration of 30 days. So if you delete your objects within 10 days, it's not the right storage class for you. And then there is a fee per object. So if you have a lot of very small objects, so in the kilobytes, talk about 20, 40, 50, 60 kilobytes, 100 kilobytes, it's not the right storage class. Right. But if you have a storage which has objects in the megabytes and they stay for a long time, and chances are that they're moving between accesses, so frequent and infrequent, then it's the really right storage class.
Thanks.
Yeah, for sure.
So I work for Digital Globe. We worked on the satellite use case, right? And one of the things that we found was the attribution is an important part of how to do that life cycling.
Yeah.
So are you guys going to kind of address how we can be able to attribute some of that data with tags or prefixes or things like that so you can know what to key off of?
Yeah, I think it's a super interesting one where I think you talk about a little bit like giving hints or telling us something you know and we don't know about that, and then based on that we could optimize. And so that's something we talk with customers. Today that's not available, so based on the service we launched 2 days ago, not. But well, as you know, the feedback we take is always considered in the roadmap. So I think the interesting part is that based on those hints, we can potentially further optimize. And so it's not in the service today, but I'll take it as feedback, and it's an interesting one.
So it's fair to say most of the access patterns that you guys have now are sort of time-based, you know, like this is the object I'm working with, and this is the time and so access patterns?
The access patterns on intelligent tiering literally looks at the access of each object. Yeah. So if you access it, like you retrieve it, it's an access. And so it looks at that.
Cool. Yeah.
Cool. Thanks a lot.
So continuing on his subject of tagging and giving it a hint. In future, it may be a good idea to give kind of a default. So default in go to S3 and otherwise, and like our pattern is media files, so large media files, which stays more than a month. So S3 intelligent makes a lot of sense. But that I know there are certain things that I want to, by default, put it in infrequent access, some objects, and some objects. So
Yeah.
that, still intelligent, but where it goes by default.
Yeah, so I think there are different ways to accomplish what you want to do. If you know that your objects are not accessed, then you should put it in standard infrequent access. I think for a lot of workloads where you know best information, that's really the right storage class.
Correct, but there are situations when it will be accessed. Like we don't
I see.
absolutely control. So
I
that's
see.
why the
Okay.
intelligence
Yeah.
makes sense.
Yeah.
So other question is that you said 0.002 something per 1,000 objects. So I'm assuming this intelligent storage is at bucket level or is at object level.
I didn't hear the question, sorry.
Can this configuration be set at bucket level or at the individual object?
It's on an object level. So the tiering and the monitoring is on an object level. The fee for monitoring and automation is $0.0025 per 1,000 objects per month.
Okay.
So that tells you the larger the object size, the less the fees in comparison to the state.
Did you say per month or is that one-time fee?
It's per month. So we monitor, we don't stop monitoring. So the monitoring keeps on. I think in the example I mentioned before, if the access pattern is changing, we need to monitor, which means we incur costs, and that is really per month, yes.
Correct. So our math needs to work out ultimately, right?
I see.
Thank you.
Yeah, thanks.
So one of the things you mentioned was the minimum storage duration
Yeah.
for using that. So is it the total from the time we put the object, or does the storage duration begin after the auto tiering has happened?
Yeah, the storage is so the storage duration, if you put it in standard IA or intelligent tiering, which both have a minimum storage duration, it starts when you put it in there.
Okay.
And the idea is that it's really for long-term storage. So if you want to delete your storage because you have a workload that deletes the storage after, let's say, 10 days, then S3 standard would be the right storage class for you.
Got it. And what is that minimum duration? 30 days or?
The minimum storage duration is 30 days, that's correct, yes.
Okay.
In S3 intelligent tiering.
Right. Another thing you mentioned was with intelligent tiering, anytime you access the thing, the clock reset, and so you would monitor it, and if it has not been accessed in last 30 days, it would get moved back to infrequent access tiering.
That's correct. So if your data is in infrequent access because you haven't accessed it for, let's say, 4 months, and then you access it, then it moves to frequent access tier. And there, the clock resets, essentially.
Got it. And also you said that it's at a per object level. So we could set the storage class to either standard or intelligent tiering at bucket level,
That's
but then with every put call, we can override and specify what we want.
I see, yeah. So today, in a certain bucket, you can have multiple storage classes. So
Right.
you can have, so one object is always stored in one storage class.
Right.
And you can have in a bucket multiple storage classes, that's correct.
Got it. Okay.
Cool.
Thanks.
Yeah, thanks. Any more? Otherwise, I stick around here for some time as well.
Hi.
Hey.
So it sounds like the intelligent tiering is a really nice option. Is the intention for just standard to move to that, since you're already doing all the monitoring, since you have all that information in there, just to help overall with standard being the option of going to infrequent access?
Yeah, I think in S3 standard, we don't monitor your access pattern, right? Neither in any other storage class. And so because we monitor it in this S3 intelligent tiering storage class, we are able to optimize between those two access tiers. So again, S3 standard doesn't have a minimum storage duration and doesn't have any retrieval fees. So there are workloads where S3 standard is really the absolutely right storage class. There are other workloads where it's not. And so I think the S3 intelligent tiering is a new storage class for changing access patterns and unpredictable ones. So it adds to the portfolio, but I don't see it as like a replacement.
I see. Okay. Thank you.
Thanks a lot.
One more question.
Yeah, sure.
So you said that intelligent tiering is not useful for very small object,
It's-
for less than
if you're-
128 KB, right?
That less than 100 kilobytes? Yes.
128 kilobytes.
That's correct. So
Right.
objects below 128 kilobytes, you can store them in S3 intelligent tiering, but they will always stay in the frequent access tier. So the documentation talks more about that,
Okay.
but you're correct.
So basically, a user would still be charged the fee, but it will never move to infrequent access tiering.
That's correct, because we still monitor it. We don't know the object size until you store it there, and that's correct.
Okay.
Yeah.
One more question. This is about
sure.
the deep glacier,
Deep archive, yeah.
deep archive. So the difference between that, the regular glacier we have, and the deep glacier, is that the retrieval time is in hours or days?
Yes, I think it's really for like if you want to keep your storage very long, and the price point is a fourth of S3 Glacier, right? And so the idea is that you hardly retrieve it at all, or maybe don't even retrieve it at all. And so it's in the hours. In S3 Glacier, you can select between minutes and hours.
Correct. And then this is just a in general question about Glacier. When we do a delete, so let's say I take an object, I know that I'm not going to access it for a long, long time, put it in Glacier. Is delete considered as an access or delete?
So in S3 Glacier, there's a minimum storage duration as well. It's for 90 days.
90 days, yeah.
And so those minimum storage durations, they really reflect the intention of the storage class, right? So the intention is as a long-term archive. And so the intention is not to delete it with 90 days. If you delete it, you can, but you get charged for it.
And the deep archive is also 90 days minimum duration?
No, the deep archive is not. It's in the documentation. I believe it's 180 days.
100 and?
I believe it's 180 days. That's something I would need to double check.
Perfect. I'll check it.
Yeah, thank you. Well, thanks everyone.